So we started this chapter with the basic geometric terms and vocabulary. We moved into triangles and quadrilaterals and other polygons as well. Let's continue that discussion and talk about how polygons can be congruent and what that means, and how that can help us to solve for missing values. We're going to write congruent statements today, and we're also going to use properties of congruent figures to solve for missing measures of polygons. Copy down that target, and then we'll get started. So congruent polygons have the same size and the same shape. They're exactly the same. A triangle cannot be congruent to a quadrilateral. A triangle can be congruent to another triangle, though, only if they're the exact same size and shape. In congruent polygons, corresponding angles are congruent. Corresponding means that they relate to each other. Think about those parallel lines. We saw the word corresponding before. When you have a transversal cutting your two parallel lines, we could say that this angle here corresponds to this angle here because they're both in the same position at each intersection, right? And this angle over here on the east side of the intersection is congruent to this angle over here on the east side. Those are corresponding angles. Same idea in congruent polygons. They correspond if they're in the same location or if they're the same angle. So when you look at these two triangles, triangle ABC is congruent to triangle DEF, and then you know that angle A is congruent to angle D. They're both this skinny little angle. I could turn this triangle upside down and A would still correspond to D because they're both the skinniest looking. Then angle B corresponds to E because they're both the ones that look to be close to the right angle. Maybe they're 90, maybe they're not, but they are congruent. And then angle C corresponds to F, so that's the medium looking angle, and those would be congruent as well, if you know these polygons are congruent. You also know then that corresponding sides are congruent. So side AB looks to me like the second longest side would correspond to the second longest side over here, which would be side DE. And side BC, the shortest side, would correspond to the shortest side over here, side EF. And then the longest side over here, side AC, would correspond to side DF over here. In a congruent statement, the vertices of the second polygon must be written in the order of correspondence with the first one. So since angle A looks like the smallest angle, if you start by naming that first polygon ABC, and when you name a polygon, you just go around. It doesn't matter what point you start at, it doesn't matter which direction you go, but you do go around in a circle. So that first statement went A to B and then B to C. You must go around in a circle, you can't skip across. So we have A, B, C. Then you name the second one to match the first. So I would start with the skinniest angle over here, and I would go to E, and then I would go to F. The order must match. And the nice thing about these congruent statements is then when you look at the congruent statements, you know which angles correspond. Angle B would correspond to angle E because they're both in the center. Side AB would correspond to side DE because they're both the first two letters. Now, you can name a polygon in many different ways. So here's another congruent statement. The order doesn't matter, just that the order of the second polygon matches the first. So here's three examples, and I put a ... because there's other ways you could say that these two triangles are congruent. So I know that was a lot of talking, not a lot of writing, but make sure you understand that. Let's put this into action then. Write a congruent statement for the polygons and fill in the blanks about the angles and the sides. So you can write one whole congruent statement for the whole figure. These are what type of polygons? 1, 2, 3, 4, 5, 6. They are hexagons. So let's pick a point to start at and name it, okay? I would pick an angle that looks familiar to you, or if the vertices are in alphabetical order, pick an order that's alphabetical. In this first one, I would start with A because I noticed that there's A, B, C, D, E, F. So that's just what I'm going to do. A is the 140-degree angle, and I'm going to go around this way. So from the 140-degree angle, I went to the 90-degree angle. A, B, and then just keep going. C, D, E, F. I could not say A, B, E, C, F, D. You got to go in a circle. Now when you name the second one, you need to match the first and look at the angles. So I started with the 140-degree angle, what are you going to start with over here? The angle that corresponds to that. So it would be V. Then which way am I going to go? Well, I went from the 140 to the 90, so I'm going to go from the 140 to the 90, and now you just go around in a circle. So VT, then keep going. VT, Z, Y, X, W. You've already said V, so don't put it in there again. That's how you name a polygon in a circle going around, and that's how you write a congruent statement. That is just one congruent statement for those two hexagons, okay? There's many ways you could write that. Now, within that statement, you can use the statement to tell me what parts are congruent. Angle A is congruent to what? Well, A is the first angle in this statement, so it would correspond to angle V. You don't even need the picture, you can use just the statement right here. And side ED is the same as DE, right? I can flip it around. So those are the 1, 2, 3, fourth and fifth letter. 1, 2, 3, fourth and fifth letter. And I said E and then D, so I'm going to say X and then Y. It's the same segment if you say Y and then X. I just like to match. So if you don't have a picture, you can still identify what angles and sides are congruent by the congruent statement. Try B, pause it, try B, and then press play to go over it. So you can have a lot of different statements here. I started with X, X, W, V, U is congruent to. I went from X to W. I went from the 1, 2, 3, 4 marked angle to the 1, 2, 3. So over here, I'm going to start with the 4 mark angle and go to the 3. So it'd be H, T, and then I just keep going around A, M. Now you may notice that that word over here looks kind of familiar. You could choose to write it having it spell a word. If I wanted this to be math, then you would have to make the other one match. So I started with the 1 and I went to the 2. Then over here I would start with the 1 mark angle and go to the 2. It would actually be U, V, W, X. Those are just 2 of the statements. You could write it 2 other ways, guys. You can write it backwards. You can write it multiple ways. From your statements, what would angle U be congruent to? In this one, angle U is my last one. It would match up to M. In this one, angle U is my first one, but it still matches up to angle M. So it doesn't matter how you write the congruent statement as long as they match. Side WV would match up with TA. So if you wrote a different statement up here, but you have these correct, chances are you have those statements correct. Make sure you matched up the corresponding parts. I put 2 pictures up here because, you know, we see congruent polygons a lot of times in construction and in architecture. We look at these windows. These windows were created and the triangles appear to be congruent. So we find congruence and symmetry really attractive, and we use it a lot when we're building things, and artists use it as well. So I just want to show you an example of where you might see congruent polygons. That could help you to find, you know, if your window broke, to be able to know what size window you need, or if just one of these triangles broke, you could know you could just measure the other one because they're congruent and it would be the same. Last part then, if you have 2 congruent polygons but you don't have all the numbers inside, you can use the idea that corresponding parts of congruent polygons are congruent to solve for them. So let's solve for T, Y, X, and Z here. Given that the 2 figures are congruent, so you do know that they are congruent, you can match up the corresponding parts. I think it helps to write your congruent statement. So let's write a congruent statement for this. And again, when you're looking at these 2, I would pick a distinct vertex to start at so you have an easy time matching it up. I'm noticing that these 2 short pieces are the only short ones. So I'm going to start my congruent statement with that just so I can, you know, make sure I'm writing it in the right order. I'm going to start with C, and C goes to the one that's going out. So I would say CG, then keep going around in that circle. FED is congruent. Now over here, make sure you match it up. Notice how C went out to G, and C was 120 degrees, and then G goes across the really long one. Well, this is the really long one, so I'm going to start with S and go to R. S, R, A, Z, M. Now we can use this congruent statement to help write some equations to solve for some values. So the first variable we might want to solve for you can start with multiple here, but I'm going to start with the side length because there's only one variable on a side length, so let's just start there. To find x. Well, x is along the side of AZ, and AZ would be congruent to what side? Well, AZ would be congruent to FE or EF, so now I can set those equal. 3x plus 2 must equal whatever's on EF. EF over here is 14. So I like to pull my equation out of this congruence statement. Then you can just solve that equation. To get x by itself, subtract 2, and then divide by 3. One variable down. All right, let's solve for another one. Well, you know what, I'm going to go with y because y is also on the side, and then I'll have all the sides done. So to find y. Again, where is y? Y is along GF. So look in your congruence statement. GF is right here. It's the second and third letter. Then it must be congruent to the second and third letter over here. So the side GF is going to be congruent to RA. Write an equation from that. If they're congruent, they have the same lengths. So y minus 3 is equal to RA, which is 10 over here. Solve for y. And we have two variables solved for. We have two angles then left to find, right? Two variables in an angle. All right, well let's go with T. Okay, T is right here in this angle R, in case it's hard to tell for you. So T is in an angle R. And I know angle R is congruent to what? Well, angle R is the second one right here. It'll be the second one over here. I really like that congruent statement. It helps me a lot. So angle R would be congruent to angle G. Sorry guys, actually I made a mistake here because when, yes, angle R and angle G are congruent, but there's no measure over here in angle G, so we wouldn't be able to solve that. So actually I think this 2T goes in angle S. So to find T, angle S would be congruent, angle S is the first one, to angle C, and that would allow us to solve because we do have an equation. So this is hard to tell where 2T is, but 2T is in the S angle. So 2T then must equal whatever's in angle C, which is 120. And you can solve for T. And the last one, angle, letter Z. So Z can be found in angle A. To find Z, I know angle A is congruent to middle letter, angle F. So I can say that Z over 2 is equal to 150. To solve for Z here, get it by itself, and I'm going to put a bar on Z so you can tell the difference between my Z and my 2. Z is being divided by 2, so I would multiply by 2. Those will cancel on the left, and I have Z is equal to 300 degrees. There's an extra challenge one in your notes. Go ahead and try it if you'd like, or if you have extra time after your quick check. It's going to be like example 2, but it's a little tougher, and you're going to have to actually remember the sum of the angles of a pentagon to solve for y.